Question 14a states the curve C is defined for t greater than or equal to 0 by the parametric equations x equals t squared plus t and y equals 4t squared minus t cubed. Find the gradient of C at the point where it intersects the positive x-axis. First, we need to find the value of t that corresponds to where the curve intersects the positive x-axis. We can do this by setting y equal to 0 and solving for t. Factorize the quadratic. The factor of t squared gives us a solution of 0, and the factor of 4 minus t gives us another solution of 4. If we substitute t equals 0 into the equation for x, we can get an intersection point of 0, 0. This is not the point we want. If we substitute t equals 4 in, we get an x-coordinate of 20, meaning our intersection point with the positive x-axis has coordinates 20, 0. We're going to need the derivative of the curve. To find the derivative, we need to use the chain rule with our parametric equations. Differentiating our parametric equations gives us the following. We can substitute dy by dt into our chain rule. To get dt by dx for our chain rule, we just need to flip dx by dt. Finally, we substitute our value of t into the derivative to give us the gradient of minus 16 over 9. Part B then states the area enclosed between C and the x-axis is given by the integral from 0 to b of y dx. Find the value of b. First, let's recall the x-axis intercepts from Part A. This would be the area bound between the x-axis and the curve. We can find this area by integrating the curve from 0 to 20, so b would be 20. B part 2 then asks us to use the substitution 4t squared minus t cubed to show that the area is given by the integral from 0 to 4 of 4t squared plus 7t cubed minus 2t to the 4 dt. We can first substitute y with our parametric equation for y. Next, we need to use the parametric equation for x to replace both the limits and the differential. We can recall from Part A the values of t that gave us our limits for x and use these limits of t instead. To convert our differential from a dx to a dt, we need to differentiate the parametric equation for x. Multiplying out the brackets leaves us with the final answer. B part 3 now asks us to find the value of a. Integrating leaves us with the following. Substituting in the limits leaves us with the final answer of 1856 divided by 15.